Okay, so one of the things I'm trying to show on these past YouTube videos of the process of BFE is how to leverage GIS in a small project. You know, because typically GIS is used for analytical purposes across large geographical areas. But in this particular case, I stumbled across a process that is very localized, very pinpoint, but at the same time, I found ways to let GIS help in contributing to solving problems for a very small area. Because what happens, and the way it's worked in the past, if you haven't seen the videos, is these are all projects. These are all specific requests for a certain location. And I've set up a process where I click on this new BAT file, and it actually generates a folder with the date and time stamp. And then it copies some GIS and shortcuts and workbook files into it to specifically for this process, which is the base flood elevation determination. and you know, I think it has value to homeowners. And what I think it has value is showing how you can use GIS in a more localized way. Because what happens is this seed file, once you open it, let me open it up here. This is what it looks like. And this is basically the process that we set up in our previous videos is for this Cabell County right here. So this is it. This is pre-established layers that have been staged here in this project file to determine BFEs based on GIS processes. And that's really not what the video is about, but it fits into it. I wanted to show you a small thing that I did recently that it's helped out that process tremendously, at least in my opinion. Because, you know, besides bringing all this information together into one point, I created some models and tools here to help, because one of them was determining a basin square mile. And let me show you how that's done real quick so this idea of tools can be more apparent too. So when you're calculating a BFE, one of the most important things is how big the basin is. So one of the layers that has been staged is raster layers that show the streams, and a directional layer that helps you calculate the basin. And here's how that's done. So if I click on this tool, it asks me to go find a coordinate. So I'm just going to pick a good one here that I can see, and then I select the flow direction. Now in this particular case, there's only one. But I have a selection here because it makes it more modular. But then I run it. Look how quickly this, pulling together a couple steps, and staging some GIS layers, how functional this makes the tool, for solving problems. So in that short period of time, I was able to calculate the basin to that point. So this is the basin. And then also established like a default style to load to it to make it more functional. And what that does is it calculates the square miles for that basin, because that's what you need when you're calculating the base flood elevation for that particular what would be that cross section at that point. So that's how this tool, and I have to say that I really like the way that QGIS has integrated their tools into their product here, because one of the things that is very much default is this interactive selection of values, and that's like this idea of selecting the coordinate like we did just now. That is built into it. Now, I've used the ArcGIS product for quite a while too, and I don't think it's that easy. Excuse me, as this. So consequently, I've created more tools in this process to to assist me, and that's what gets me to this next tool that I want to show you and how it came about. It's actually the contour tool. And it's this one right here. And so this is the results of it. This is actually some contour layers that I quickly generated. They're actually for a very small area. It's this area I select, just like we did here under the basin as far as selecting coordinates. Under the contours, I select the area. So let me show you how functional this is, and this is pretty cool. I'm going to turn these off. I'm going to do a new one. So I'm interested in that one area there. So look how easy this is. So you guys select a DEM because actually what it's doing is just extracting the extents of the DEM, and I can use either the canvas or select, and I'm going to select because I think that's just so cool because it lets you do what you want. And here I put a selection, put the variable that's the interval. So this, in this case, my DEM is in feet, so that's in feet. So right now it's 10 feet. But I can select 2 or 3. So let's go ahead and keep it on 10 though. We'll keep it. Oh, let's do this. We'll make it 5 and run it. So what it does is it extracts that DEM and then it runs contours on it. So that's it. That's how quick that was. So very quickly I have a set of contours for a specific area that I want to look at the look at elevation in a different way, because I do have the DEM there. You can look at the DEM as a transparent raster file, but what I like about these contours is how they look on aerial photography, because it's really a little bit more difficult to start putting numerous amounts of raster layers on top of each other, and then you have transparency things that you got to work out. But here, check this out, how that looks on top of the aerial photography. And then just like the other one, I created a small style file that lets me make it look more functional, even more functional. So then I labeled it and used transparencies and did a lot of different things so I can label these contours all in feet. Then we could do some neat stuff. Let's see, what did I say that was? We did it as 5 foot. So let's do it as like that. I think because that's a temporary layer. If it was a file that I actually created, it would probably do that. So now I'm going to do it, make it like 25. So then I'm going to load that same style. Load the style. Except this time what I want to do is go into the weights right here and make it a little bit heavier. And there very quickly I have some what looks like a more traditional topographical contour map from like USGS. And very quickly and in a very quick way that would let me, if I wanted to include this on this small project where I'm assisting somebody, I could very quickly capture that in a screen capture and send it to them by email, or in some way to open up the discussion on this particular area in a geographical way. So I think this is just I'm very much enjoying these tools and these capabilities that come with QGIS. The one thing I want to show you here that often happens on these references we use for doing BFEs, which this is the National Flood Hazard layer, this layer right here that I have the transparency set to where you can hardly see, is they did this model previously using different topography. In this case, the topography we call the DEM. And when you turn this on, it lets you see very quickly, if that matches this existing digital elevation model that I have. And it looks like in most cases, in some cases here, that, we're using a newer layer and the elevations don't necessarily match up. So that becomes an important part of this discussion that we're having, this technical discussion that we're having in this very small area, most of the time with surveyors and homeowners. And it's a very big plus, and I'm pretty excited about it because it very quickly lets me collect and put geographical information into the hands of professionals and homeowners who have to make decisions. So thanks to these tools that we have available, we can do that. So what I want to show you in a future video is how this model tool was made that creates these contours. I mean, it should cover everything that a tool can do, or a lot of the things that you would want to do in a tool. So that's what I want to do in the part 2 of this video. So stay tuned.